For decades, we've been obsessed with building AI that can do stuff, play chess, drive our cars, diagnose diseases. But we've kind of overlooked a much more subtle and honestly, a more profound kind of intelligence. The ability not just to know something, but to actually teach it. This is the world of pedagogical intelligence, and today we're going to break down how it works and why it's pretty much the future of AI.
So let me ask you this, because it's really the question at the heart of our entire discussion. We've all had that brilliant professor who just couldn't explain their own ideas, right? And then we've had that amazing teacher who could make anything, even the most complex stuff, just click. Well, it turns out that's not an accident. Knowing and teaching are fundamentally different skills, and figuring out that difference is unlocking a whole new frontier in artificial intelligence.
All right, here's our roadmap. First, we'll define this forgotten intelligence. Then we'll dig into its biological roots and see how we can translate that into algorithms. After that, we'll take a walk through the history of AI tutors, see what's happening with the large language model revolution, and wrap up by looking at why a human-centered approach is the only way forward.
We are right in the middle of what a lot of experts are calling the pedagogical turn in AI. The goal isn't just to build a genius AI anymore. The new goal is to build an AI that can make you a genius. It's a massive shift in thinking, really, from pure performance to pure empowerment.
Now, this slide really gets to the core of it. On one side, you've got your classic general intelligence. That's the AI built to just solve problems. But over on the other side, you have pedagogical intelligence. Its whole reason for being is to model someone else's mind and figure out the absolute best way to get them from A to B, from novice to expert. So think of it like this. A chess AI has general intelligence. It knows the best move. But an AI with pedagogical intelligence knows the best way to teach you why it's the best move. Big difference. And this isn't some brand new idea. Howard Gardner, the guy famous for the theory of multiple intelligences, he saw this exact same thing. He noticed all these brilliant scientists and incredible artists who were just completely incapable of teaching their own craft. And that proves it. The ability to teach isn't just a side effect of being an expert. It runs on its own, totally distinct cognitive machinery. Okay, so where does this special machinery even come from? Well, it turns out it's baked right into our DNA. See, teaching isn't just some cultural thing we invented. It's a biological adaptation that gave our species a massive evolutionary edge. Let's dig into how that works. The official term for this is natural pedagogy. So while other animals learn by just watching and copying, they're basically stealing information, humans evolved this unique system to gift knowledge directly. We are biologically hardwired to both teach and be taught. It's a system designed for the super fast transfer of complex stuff, like, how to make tools or build entire societies. And this slide illustrates the core mechanism perfectly. It's called the ostensive signal. Just think of it as a biological, hey, listen up, cue. It's the difference between a little kid just seeing a ball roll by and a parent making eye contact, pointing directly at it and saying, ball. That simple act, that signal, it transforms a random event into a laser-focused learning opportunity. It's telling the child's brain, hey, pay attention, this is important and it's for you. But wait, it gets even more sophisticated. Truly effective teaching requires something called recursive mindreading. So level 1 is simple. I know what you don't know. Level 2 is when the student knows that I'm intentionally trying to teach them. But the real magic, the secret sauce, is that third step. I actually change my explanation because I can predict how you're going to interpret my intentions. It's this incredible mental dance, and it's what separates a good teacher from a truly great one. So, okay, we've established we have this deep biological instinct for teaching. The next big question for computer scientists was obvious. Can we turn this art into a science? Can we actually translate this human instinct into an algorithm a machine can run? This slide just captures the computational flip perfectly. Machine learning, which powers most of the AI we hear about, is the learner's problem. You give it a mountain of data and it has to find the pattern. Machine teaching is the total inverse. It's the teacher's problem. It asks, okay, I already know the pattern. What is the absolute smallest, most perfect set of examples I can give you so that you learn it as fast as humanly possible? And that leads us to this really cool metric, the teaching dimension. So imagine you're teaching a kid what a square is. A less than great teacher might show them hundreds of examples. But a great teacher, they know they just need to show a perfect square, and maybe a rectangle right next to it to highlight the difference. That's a low teaching dimension, getting the most learning with the least amount of data. It's all about efficiency. All right, so with these mathematical tools in hand, computer scientists have been trying to build AI tutors for decades now. And their journey has really unfolded across 4 distinct eras, with each one representing a pretty big leap in the machine's ability to actually model a student's mind.
Let's just walk through this real quick. We started back in the 80s with these super rigid, rule-based systems. If the student gets X wrong, then show them Y. Then in the 90s, things got smarter with Bayesian models that could actually guess what a student knew. The 2010s brought deep learning, which made those guesses incredibly accurate. But we kind of lost the why behind them. They were black boxes. And that brings us to today's frontier, POMDPs, which can actually think and plan like a real teacher.
So, a PMDP lets an AI tutor think like a grandmaster, but for teaching. It's planning several moves ahead, deciding when to explain something, when to give a quiz, and, this is the cool part, when to let a student struggle a little bit. It knows that this desirable difficulty, as they call it, can lead to a much bigger breakthrough later on. It's not just about getting the next right answer. It's about playing the long game for deep, lasting learning.
And just as these POMDPs were really hitting their stride, everything changed. Large language models showed up, and they didn't just pick content from a library. They could create it from scratch, on the fly. And this opened up some incredible new possibilities, and also some pretty serious risks.
Right now, LLMs are playing 2 major roles. On the left, they're amazing content generators. They can create infinite practice problems, or like with this Hippocampus system, they can even generate buggy code for computer science students to learn how to debug. But the much more powerful role is on the right, the LLM as the teacher itself. Here, the model isn't just making stuff, it's running the entire Socratic conversation, adapting in real time to whatever a student says or asks. But of course, there's a huge problem: hallucinations. An AI tutor that confidently teaches you something that's just flat out wrong, that's basically pedagogical malpractice. And this is so important because trust is everything in education. But look at this chart. A standard LLM might have a 32% error rate in some types of math problems. That's terrible. But with new techniques like self-consistency, where the model essentially double-checks its own work, that error rate just plummets to less than 1%. We are getting so much better at making these systems safe and reliable. And all of this brings us to the final, and I think the most important piece of this whole puzzle. It's not enough for an AI teacher to be smart and strategic and correct. It also has to be fair and empathetic and emotionally aware. This quote right here highlights a massive challenge called the reading confound. An AI tutor sees a student fail a math word problem, and it just concludes, oh, they're bad at math. But what if the real problem is their reading level? The AI then gives the wrong kind of help, maybe even simpler math problems, and it just creates this awful cycle of failure. This isn't just a technical glitch, it's a fundamental problem of fairness that we have to solve. So to fight this, researchers are essentially building an ethical checklist right into the AI. They're forcing it to ask these tough questions. Can I recognize mastery equally well no matter a student's background? Am I just as good at spotting struggling students across all groups? And this is the big one. Would I have made the exact same teaching decision if this student's race or gender were different? These are absolutely essential questions we have to get right. And at the end of the day, the peak of pedagogical intelligence isn't just cognitive, it's affective. It's about emotion. A truly brilliant tutor has to manage that emotional roller coaster of learning. It has to sense frustration and offer encouragement, detect excitement and maybe push a little harder. The future of this field means programming not just logic, but also warmth and trust. Which leaves us with this final and, I think, crucial question. As we get closer and closer to building these incredibly powerful artificial teachers, we have to decide what values we want to encode into them. Because in teaching them how to teach us, we are ultimately defining what we believe is most important to learn in the first place.